Hello and welcome back. This time we want to talk about analog inputs. Okay, we've talked about analog outputs. We said okay, it's not really analog because we just can turn it on and off very fast that it looks a little bit like analog. So we do pulse width modulation. On our Arduino we have also analog inputs. However, these analog inputs are not for pulse width modulation. They are real analog things. This is why they are also separate inputs. Okay, they are located down here. They are labeled with A0 to A5. So we have 6 analog inputs. 0, 1, 2, 3, 4, 5. Each input can handle usually between 0 and 5 volt. If you want to use another voltage level, please refer to the specs. There is also a reference voltage input here. You could connect it. However, out of the box, we are using 0 to 5 volt here. But in difference to the digital inputs, we are not using exactly 0 and exactly 5 volt. We are using something in between. So we can use whatever between. The question now is, how do we produce a voltage between 0 and 5 volt? I mean, our Arduino has an output of 5 volt. Okay, 5 volt, no issue. Has an output of 3.3 volt, also 3.3 volt, no issue. But I mean, these are discrete voltages. How do I divide this voltage or somehow produce from a bigger voltage a smaller voltage? I will now show you how this might happen. Yeah, I take a 2 kilo ohm resistor, place it between plus and some input. I have not. Okay, now it felt different. Between plus and an input. And I will take a 1 kilo ohm resistor. Okay. Place it also. This one I will place between this point and minus. So from plus to minus I do have in total 3 kilo ohm. It's not too easy to plug it in. You will get used to this. Okay. So these are my 2 resistors from plus 2 kilo ohm, 1 kilo ohm to minus. I will again make the connections on this side. I do not have to care about plus and minus. What does it mean? Yeah? Let's see. I have here a measurement device. Turn it on. I will measure the ohm now. Right now it's on overload, so I measure between here and here, and of course I measure this 2 kilo ohm here, around 2 kilo ohm. I measure between here and here, and I should measure this 1 kilo ohm. Yes, 0.9 kilo ohm. And from here to here we do have our 3 kilo ohm. So in total we have 3 kilo ohm, 2 and 1. From here to here 2, from here to here 1. Now let's see, what does this mean? What does it mean for the voltage levels? I will simply connect plus and minus, so plus 5 volt. I will connect to plus. Ground I will connect to the minus bar. And I power it up. The good thing is it's still, the LEDs are still on. In this case, if your LEDs are turning off, yeah, then you have somewhere a short circuit here. If you directly, shortly show you, please don't do this with your Arduino. If you connect plus and minus, yeah, you will see how this LED go dark. Ooh, you have seen? Ooh, this is because we take too much current from here, and this Arduino dies then. Yeah, if you don't stop it or they don't disconnect it, these chips here will get very hot. Yeah, and then they will start to burn, and then it will. Then this was everything you will ever again have from your Arduino. So I said voltage level. Let's take the voltage level. Of course, we should be able to measure here our 5 volts. Yeah. I'll try this now. From here to here, 4.8 volts. Okay, working. Yeah. How much do we have from here to here? 3.2. Aha, interesting. 3.2, and from here to here I have 1.6. Okay, why is this? Because this resistor is double the size than this resistor. So here we need double the voltage to here, because the flow of the current flow, yeah, the flow of charges is constant. From here to here, here the same amount of charges flow like here. Yeah. And to overcome the big resistor, we need more voltage drop than to overcome with the same amount of charges running through to overcome the small resistor. Okay. Depending on the resistor voltages, on the resistor values, this voltage level do differ. Yeah? Like I said, here we have 3.2. Yeah? Here we have 1.6. Yeah? And in total we have this 4.8. Yeah? If I now simply take this out, this 1K resistor, yeah, and use another 2K resistor to connect, would you still expect that we do have again the 3.2 volts here? Let's have a look. Now we only have 2.4. Yeah. And here we have also 2.4, and in total we have again our 4.8. Okay, so this time I changed the resistor values. Both resistors are now the same size, so we need the same amount of voltage drop to drive the charges through the resistors. So I can select how much voltage I have at this point. If I measure here, yeah, first I had 1.6 and now I have 2.4. Depending on the value of the resistors, I can select the amount of voltage I measure at this point. Okay? And this type of network, let's call it network, I can use to select to select a certain value. Okay, to select a certain value. However, if you really have to, or all the time have to unplug and replug a resistor, it is not very practical. Yeah. So you do have in your starter kit, you do have a thing like this little fella here. This is a so-called potentiometer. It has, will it get sharp? No, autofocus is not really working. However, it has 3 legs. Yeah, it has 3 legs, and you can select the resistance value. How is it working? I'll plug it in here at this point in my breadboard. It fits in quite nice. Also use here gentle force. There's also a nice handle. You can use it. Simply push it in, and then you have a small stick, and you can turn. You can turn the knob. You can turn the knob, and it should work. How does it work? At one side, I will connect minus. At the other side, I will connect plus. Yeah. Please always, like I said, always watch if the lights are going out. If they are going out, you have done something wrong. You have a short circuit. Yeah. And now I want to know, again, here is my measurement device. Okay. Let's see between here, cables, huh? Always doing like they are alive. Measure between here and here. I measure minus 4.3. Why 4.3? Before I measured 4.8. I will now unplug those two, because now I start to overload the output. Let's see how much do we have now. Do I reach them somewhere? No, nothing. I do not reach them, alright? Why is that? Plus? Let's see. Measure between here and here. Also 0. What's going on here? Maybe it's a teachable moment. 4.8 volts, like before. Okay, finally. So I plug this in here now. I should also be able to measure 4.8 here. Yeah, now it's working. 4.8. Plug this in again here. Back. Okay, and now I want to measure the voltage level between this point, the third connector, and this point. Currently I have 4.6, 4.5, 4.6 around this. Yeah. Now I make a slight turn, measure again, 3.9. Yeah. I can adjust the voltage level by simply turning the knob. Okay, if I turn the knob down on one direction, 2.5 and so on. And the further I turn the knob, the less voltage I will measure. Okay, this thing here is called a potentiometer. This one we will use to measure, to test our analog input. Okay, so one end plus, second end minus. Yeah. In between, we do not have, like before, 3 kilo ohms. We do have 10 kilo ohms. That is why it's written on the 10K. Yeah. And here, this is the so-called sliding contact. We can select where we want to have the sliding contact, here on this side, yeah, or we can turn it over to this side. Yeah. One time the contact is directly connected to ground, so between here and here is 0 volts. Yeah. And one time the sliding contact is connected directly to plus 5 volt, so we have plus 5 volt from here to here. And we can position the sliding contact everywhere between, and so the voltage will be divided in a big part and a small part, in 2 parts, let's call it, depending on how much I turn the knob. So I will now connect the output of the potentiometer to the input. Okay, I will now connect this to the input, and now we have on the input here voltage levels between 0 and 5 volt. That's exactly what we wanted to have. Okay. How do we proceed, or how do we address this input? Yeah, I will make a new program. Yeah. I will call it. I will save it. Under the name three MBA Dashowski 10 analog input. Save. We can have a new thing here. I will immediately define ana in 0 compile time constant. Yeah. This time I do not have to select if this is an in and output, since those pins down there, they are for sure an input. Yeah. However, we do have, I will start the serial.begin, yeah, 9600. I will also make a print dot serial dot print line init done. Okay, and here I will make an integer variable. Yeah, I will call it value val. Yeah, and this time I don't make a digital read, I make an analog read. Okay, that's the corresponding command to read from the analog input. Okay, analog read input. From where? Ana in 0, and that's it. That's about it. And I want to know what's the value? What do we get here? Yeah. So I'll simply, since I don't know or I don't like to read, yeah, since I simply make a printout, serial.print, yeah, read serial.println value, and that's it. So I simply read from the analog input and write it to the serial output. Download. It's compiling, looks good. I'll open the serial monitor. Okay, we have some value here. Yeah, it's going up and down. If I grab it, it's a little bit more firm. This is simply because I have here sometimes with the big foots, with the big things, yeah, of this potentiometer, I sometimes have troubles. Okay, so let's see. I turn it to the one side. I reach 0. Yeah? So one end seems to be 0. Yeah? Then I turn it to the other side. And I reach 1023. Yeah? So the other side is 1023. That's 5 volts. Yeah? I now send 5 volts to the input. I get a value of 1023. I now send 0 volt to the input. Yeah. 0 volt to the input. Yeah, here 0 volt to the input. A value of 0. So, and if I get a value in between, yeah, I have something in between. Yeah. And if I turn it in the middle, I should have around 512 or something like this. Yeah. Okay. So, what does this mean? This means I'm getting a number based on how much voltage is there. Yeah? 0 voltage means 0, 5 volts means 1023. Why is this? I do have 10-bit analog digital converter on there. So 0 volts is transferred into 10 zeros binary, and 5 volts is transferred into 10 binary ones. Yeah. So this is 0 and this is 1023. In total we divide the range from 0 to 5 into 1024, 0 up to 1023. Don't forget to count 0. Into 1024 parts. Yeah? And we get the information in which part we be. Okay? This is a little bit tricky now to understand. There's a separate video which explains this dividing into ranges and so on. You can watch this if you're interested. Or you can simply say, okay, 0 is 0 and 5 volt is 1023 and it's something in between. Yeah? Then it's in between. Good. This means I could measure now. Yeah? Because if I now calculate, so this is raw, this is the raw value, then I could calculate in percent, yeah. So this is serial dot print, yeah. This is the value divided by 1023 multiplied by 100. This you should not do. Why is this? Little side information, this is an integer value. So if the integer value is between 0 and 1023, if it's just an integer value. So this calculation will be integer calculation. So here you either get 0 or 1. There is no dot in integer. It's not 0.7. It's not coming out of this. So how to do this? You could first multiply and then divide. Is better in this case. Later, if we are learning about float values, I will show you something else. Right now, please remember this. So it's better like this. Okay. Download. Let's watch. Minus 11%. Really? That's interesting. Let's say that's at least interesting. 1023. What is happening there? Somebody an idea? The thing is that an integer value is only going up to 32,000. So if we have 1000 multiplied by 100, we have 100,000. So we are above a certain value. This is not working with integer value. So I could use here long, and then suddenly I will not touch it. Here we see 300, and suddenly you have 37%. Suddenly it's working. If I turn it on, it's running up to 100%, going down to 0%, or something in between. What happens here is that we are above the maximum value. If we are above the maximum value, we will have an overflow, and this, then something really strange coming out of this calculation. I now also can show you how it looks like if I would exchange those two. Like I said before, don't do this. Download. Now we divide it first, and here you see now we have 0%. 0, 0, 0, always 0. And only here suddenly we have 100. 0, 0 and 100. Why is this? Because here we always get 0. Only if this is 1023, then we get 1. And 1 multiplied by 100 is 100. And if it's this 1022, then it's 0 dot whatever, and the integer is only the number before the dot, so it's 0. 0 multiplied by 100. This is exactly the behavior I told you first, this does not look good. Yeah? If you multiply first with 100 and then divide it by 1023, it works much better. However, you might get into trouble with the size of the integer. Okay, now you see it's jumping between 99 and 100% and not between 0 and 100%. How to overcome this? Yeah. There is also a data type called float. And this float can hold comma values. Okay, floating point values. Okay. And this time I can make the same calculation here, like here. Yeah. And this time I make a typecast. Okay, I say, okay, take whatever is in here and make a float out of it, and then do a multiplication and dividing. Yeah? Then it's a floating point operation, and here then it's a floating point operation. And I can print out here percent download, and we suddenly see there are comma values. Yeah? There are comma values, 100, 99.6 or whatever. Yeah? Suddenly there are comma values. That's simply because it's a floating point variable. And I did this typecast here. Yeah? So whatever is inside here, make it a floating point and then do this calculation. Okay? And now I could even make another percent multiplied by 5 divided by 100. Yeah? And that's, of course, the volts. Okay? Now we also get a printout in volts, and here integer values would not have sense, because really if I only distinguish between 1, 2, 3, 4, 5 volts, it doesn't really help. But here I get a very smooth, values, yeah, with this floating point. So this is how an analog input works. And side information, how a floating point works, side information, how an integer calculation is done, and so on. Yeah? So this is also everything you have also written in your script. Yeah? There's also described this dividing of the voltage between two resistors, or with a sliding contact, that you can divide one big resistor into smaller parts and then select if you grab 5 volts here or 0 volts here, or slide it up and down and grab something in between. Yeah. Of course there is the scheme. Yeah. There's also the description of the value, and then there is the program. It looks a little bit different than what we just programmed, and that's it. Yeah. Your task here is that you should make an analog input, and you can adjust the brightness of LED. Yeah? If you turn it down, the LED should be dimmed. If you turn it up, the LED should be maxed. So this is how it should look like. Currently it's off, and if I turn, it should come on slowly, and the brightness should be able, you should be able to adjust the brightness how you like. Okay. Maybe if I turn off here the lightning, maybe we see it better then. Turns on slowly. And then we can turn it on, and on the screen it even looks like a bright star. Whoa! In reality it's not that impressive, but you see how it should work. Okay, so good luck with this, and thank you for listening so far. Okay, goodbye.